Hello, my name is Brandon, and I was working with Payne on our FRQ. Payne made the FRQ, and I'm going to do the video. So here is our FRQ. Directions are: show all your work, indicate clearly the methods you use, because you will be scored on the correctness of your methods as well as on the accuracy and completeness of your results and explanations. So, Ms. Conway's AP Statistics class recently took 2 tests. The results of their test scores are represented in the STEM plot below. You have the test 1 scores on the left, and test 2 scores on the right. The key at the bottom to show you what the 5 line 3 means is score 53. So, like 4 line 9 is 49. So the first order of business is to compare the distributions of the 2 test scores. And then B is a follow-up question, but let's just deal with A for right now. So to compare the distribution of the test scores, we have to look at our data and find the median, the mean, and then determine if it's a normal distribution or not. So for the first test score, to compute the median, you have to line up all the numbers in ascending order or descending order, but it just has to be in order. And then you go, knock off the first and last numbers, so you cross them out until you get to when you have either 1 number or 2 numbers left. And if there's 2 numbers, you have to get the average between the 2 numbers, and that's your median. Or if it's 1 number, it's that number. So in test 1, our median was 78, which means we came down to 77 and 79, and in between 77 and 79, our median was 78. So that's the middle of the data. Then to compute mean, we had to add up all the test scores and divide by the number of test scores there were. And our mean is also 78. So then we look at test 2 and the test 2 scores. In test 2 scores, the median was 86, doing the same method that we had said earlier, and this time there's 1 number left, and that was 86. Then we compute the mean the same way we did in test 1, where we add up all the numbers and divide by the number of numbers in the data, and our mean is 81.4. So when you look at this data, you can tell that test 1 is a symmetrical normal distribution. While test 2 is slightly skewed left. And then you can further look at it and see that the range in test 1 is 51, and in test 2 it's 58. With this range, you can determine that the test scores in test 2 are more variable than the test scores in test 1. Also, in test 1, the scores did not have any outliers. There wasn't any extreme numbers that seemed very far from the data. but in test 2, the score of 42 would be considered far from the data. It's not really where the norm is, and so it's considered an extreme. But in both distributions, the most students scored in the 70s or 80s, with a few scoring in the 40s, 50s, and then the hundreds. Alright, so now that we have written down all these points, we should now move on to Part B. So Part B reads, Judy has taken 6 tests in AP Statistics. Her test scores are as follows: 44, 78, 95, 33, 100, and 84. What is the probability that she'll pass at least 2 of her next 4 tests? Assume that each trial is independent and her probability of passing, 65 and above, remains the same. Alright, so I would write down first that the probability of Judy passing is 4 out of 6. How do we know this? Well, if you look at the data, and given the fact that probability of passing is 65 and above, when you look at the data, there's 4 test scores, 78, 95, 100, 84, above 65, and 2 test scores that are below the 65, 44, and 33. So given this, that means 4 out of the 6 tests she takes, she's going to pass. So then the probability that Judy passes at least the 2 of her next 4 tests, that's a binomial distribution. It says at least, and there's more than one success, so you know it's not geometric. And your probability is 4 out of 6, which is what we've computed above. That's your probability. And then x equals the number of tests she passed out of her next 4 tests. So to do this, we need to say the probability that x is less or greater than or equal to 2. So that will determine that at least 2 of her next 4 tests she passes. So we write down probability of x is greater than or equal to 2 equals the probability of x equals 2, which is that first one, plus x equals 3, which is still part of the thing, and then probability of x equals 4. So when you compute the probability of x equaling 2, you get 0.2963, and when you compute the probability of x equals 3, you get 0.3951, and when you compute the probability of x equals 4, you get 0.1975. You add these together and you get the probability of x being greater than or equal to 2, or Judy passing at least 2 of her next 4 tests, as 0.8889, or 88.989%. If you plug this into a calculator, you would simply plug in where they want the p and the x, and you can find it that way. Alright, so let's now look at the solutions, or what they're looking for in the answers. So the intent of the question. The primary goals of this question were to assess the student's ability to 1. Compare 2 distributions presented with stem plots, 2. And then number 2, analyze the probability using a binomial distribution. Alright, next we look at the solution, which we already did. You can take my word for it. It's correct. Let's skip down to scoring, because that's important. So this question is scored in 4 sections. Part A has 3 components. The first component is comparing the centers of the 2 distributions. The second part is comparing variability of the 2 distributions. And the third part is identifying the shapes of both distributions, including context related to the variable of interest. Section 1 consists of Part A, Component 1. Section 2 consists of Part A, Component 2. And Section 3 consists of Part A, Component 3. Section 4 consists of Part B. Sections 1 and 2 are scored as essentially correct E or incorrect I. Section 3 and 4 are scored as essentially correct E and partially correct P or incorrect I. So Section 1 is scored as follows. You get an E or essentially correct if the response correctly compares center or location for both distributions. You get an I or incorrect if it's other than that. Let's see. In Section 2, it's scored as follows. You get an E or essentially correct if the response correctly compares variability for both distributions, and you get an I if it's other than that. In Section 3, you get an E or essentially correct if the response includes context related to the variable of interest, test scores, and the response correctly identifies the shape of both distributions. You get a P or partially correct if the response correctly identifies the shapes of both distributions but does not include context related to the variable of interest, test scores, or if the response correctly identifies the shape of only one distribution and includes context related to the variable of interest, test scores. It is incorrect otherwise. Section 4 is scored as follows. You get an E or essentially correct if the student recognized the setting as binomial and work is shown. That is, the correct values for n and x are given and the desired probability is calculated. You get a P or partially correct if the student recognizes the situation as binomial but does not compute the desired probability. Or the student computes the probability correctly as 0.8889 but does not recognize the situation as binomial. Or the student gives the correct probability of 0.1139 but work is not shown. Incorrect if it's anything other than that. So now you're given that. So each essentially correct section counts as 1 point. Each partially correct P section counts as half a point. So 4 is a complete response, 3 is a substantial response, and 2 is developing response, and 1 is a minimal response. The responses between 2 scores, for example 2.5 points, use a holistic approach to decide whether to score up or down, depending on the overall strength of the response and communication. That is our FRQ. I hope you learned something. Thank you for listening, and I hope you enjoyed it.